if we let z sub n be the random variable with the probability density function n plus 1 times z to the power of n for 0 less than z less than 1, and we want to just show that z sub n converges to 1 in distribution, we can start by doing the following. So you'll notice that I did kind of lie a bit here, right? We need to be precise with our words. And we should mention that our density is 0 everywhere else for z sub n, and that we'll define a random variable z equals 1 for convergence in distribution. Now, before we get right into this, right, let's think about what that means to converge in distribution. So by definition, right, we have a limit as n approaches infinity of our, you can say, our cumulative distribution function, right? But really it's just the probability that z sub n is less than or equal to z as n approaches infinity should eventually equal the probability that our random variable z is less than or equal to little z for all little z, right? So we can do this case by case. If first we consider the case when z is between 0 and 1, less than 1 strictly, then our cumulative distribution function, right? This is just our definition here. We're just dealing with the integral. So we have the integral from 0 to z of our density on this interval. And then, we just have our x to the power of n plus 1, where that just comes from basic integral properties. And then we'll notice that since z is a fraction, right? That limit, so the limit of our CDF when z is greater than or equal to 0 and less than 1, as n approaches infinity, is 0. And you'll see that on the right-hand side here. So, in a moment, we'll talk about this a bit more, but just for now, let's consider the other case, right? Where z is less than or greater than or equal to 1, sorry. So then we'll have the following here, right? Because our CDF is always going to be 1 if our z is greater than or equal to 1, because our support, all of our non-negative values, happen to be on the interval from 0 to 1 for z sub n. So the reason it's sufficient to show these 2 points here, to show that z sub n converges to z in distribution, is because the CDF of z when little z is less than 1 greater than or equal to 0 is always going to be 0, right? Because z only takes on the value 1. And that's similarly the case when little z is greater than or equal to 1, right? Because no matter what, z takes on the value 1. So the probability that we're less than some value greater than 1 is always going to be 1. And then we're done.